Hello and welcome back, everyone. This video covers the Unit 7b quiz review, and the topic is radical and absolute value equations and graphs. Let's get started with number 1. We are solving this equation. It's a radical equation, so we need to get the radical by itself. So the first step would be to subtract the 4 from both sides. And we have the square root of 2x minus 5 equals 5. Now we will square both sides to get rid of the radical. And squaring both sides results in 2x minus 5 equals 25. Let's add 5 to both sides. We get 2x equals 30. And then let's divide by 2. And we get x equals 15. Now we should plug in the 15 for x in the original equation just to check to make sure that it works. So 2 times 15 is 30, minus 5 is 25, square root of that is 5, and then plus 4 is 9. So it does work, and our solution is x equals 15. For question number 2, we have the 6th root on the left and also a 6th root on the right. So let's raise both sides to the power of 6 to undo the radical. Now, raising both sides to the power of 6 causes the radicals to go away on both sides, giving us 3x plus 11 equals 13 minus x. Well, let's go ahead and add x to both sides. That results in 4x plus 11 equals 13. Now let's subtract 11 from both sides. We now have 4x equals 2. And then let's divide by 4 on both sides. So x is 2/4, which of course reduces to 1/2. Now, just to check to make sure that it works, plug in 1/2 for x. That's 3 times 1/2. That's going to be 3 over 2, or 1.5. Plus 11 is 12.5. On the right side, if we plug in 1/2, that's 13 take away 1/2 is also 12.5. So on both sides of the equation, we have the 6th root of 12.5, so they are equal to each other. And therefore, x equals 1/2 is our solution. All right, for number 3, we have this negative 12 times the radical equals 24. We want to get the radical by itself, so we'll need to divide by negative 12 on both sides. And that results in the 5th root of x plus 6 equals negative 2. Now let's raise both sides to the power of 5 to undo the radical. And the result of that is x plus 6 is equal to negative 32. Now we'll need to isolate x by subtracting 6 from both sides, and we get our final answer of x is equal to negative 38. And then just plugging it in to check, negative 38 plus 6 is negative 32. And the 5th root of negative 32 is negative 2, multiplied by negative 12 is positive 24, so our solution is valid. For question 4, we want to get rid of the radical on the right, so we'll raise both sides to the power of 2. The result is x squared equals 5x plus 14. Now this is a quadratic equation, so we'll need to get everything on one side and set the other side equal to 0. So let's move the 5x plus 14 over to the left. Result is x squared minus 5x minus 14 equals 0. Now this can be factored, and that's going to be factored into x minus 7 times x plus 2. And we set both of those equal to 0 and solve. And we get x equals positive 7 or x equals negative 2. Now we'll need to see if these answers are valid. So let's plug in 7 for x. So on the left we would have 7, and on the right 5 times 7 is 35, plus 14 makes 49, and the square root of 49 is 7. So both sides do equal 7, and x equals 7 is valid. But if you plug in x equals negative 2, right away we know that that is not valid because you have negative 2 on the left, and then you have a radical on the right, and the square root of a number cannot equal a negative value. So we end up having to cross out x equals -2. So our only solution is x equals 7. All right, for problem 5, we have the x plus 6 is being raised to this fractional exponent, and then it's being multiplied by 7. So what we'd want to do is get rid of the 7 first. We'll need to divide by 7 on both sides. So 189 divided by 7 gives us 27 on the right. And now we want to get rid of the fractional exponent, so we'll raise both sides to the reciprocal power of 3 over 2. Now the reciprocal of 3 over 2 is 2 over 3. So we're raising both sides to the power of 2/3. Now the 27 to the 2/3, the way that works is the 3 on the bottom is telling us to take the cubed root of 27, which is 3, and then you're going to square that, so that's 3 squared is 9. And on the left side, the exponents cancel out, so you just have x plus 6. So if x plus 6 is equal to 9, we'll just subtract 6 from both sides, and we get x is equal to 3. Now let's check to make sure it works. So plugging 3 in for x, that's 3 plus 6 is 9. 9 to the 3 halves, well, that's telling us to take the square root of 9. That'll be 3. Raise that to the 3rd power, that would be 27. Multiply 27 times 7, and that does equal 189. So x equals 3 is a valid solution. Okay, for number 6, we have an absolute value equation. We have 4 times the absolute value of x plus 5 equals -32. We'll want to get rid of the 4 on both sides, so let's divide by 4. And the result would be absolute value of x plus 5 equals -8. Now at that point we can stop. And the reason why we can stop is because the absolute value cannot be negative. So once you see that the absolute value is equal to a negative number, at that point you can stop. All right? Absolute value cannot be negative, and therefore our solution is that there is no solution. All right, for number 7, we have the absolute value of this fraction is equal to -8. Well, there is no need to go any further. We can actually just stop right here because, again, we have the absolute value equal to a negative number, and that cannot be. So therefore, the answer is no solution. Okay, for number 8, we have the negative of this absolute value plus the 4 equals -5. First, we will get rid of the 4 by subtraction. So let's subtract 4 from both sides, and that results in -9 on the right. Now we have this negative that's in front of the absolute value. So let's divide both sides by -1. And the result is that the absolute value is equal to 9. Now what we'll do is we'll get rid of the absolute value and then make the 9 positive and negative. So we drop the absolute value on the left, so we have 3x plus 15 is equal to plus or minus 9. Now let's subtract 15 on both sides, and that will be 3x is equal to plus or minus 9 minus 15. Now we'll take this case by case. First we'll assume that 9 is negative. Negative 9 minus 15 is going to give us -24. And then positive 9 minus 15 is going to give us -6. So we have 2 separate equations that we're solving. Let's solve the equation here. 3x equals -24. Dividing by 3 on both sides, we get -8. And if we divide by 3 on this equation, we get x is equal to -2. Plugging in -8 into the original equation, that's 3 times -8 is -24, plus 15 is -9. The absolute value makes it +9. The negative in front turns it back to -9, plus the 4 is -5. So that's valid. Now let's let x equal -2. 3 times negative 2 is negative 6, plus 15 is positive 9. The absolute value is still 9. The negative in front turns it into negative 9, plus the 4 is negative 5, so that is also valid. So both answers are valid. All right, for number 9, we have the absolute value minus 5 equals negative 2. Let's go ahead and move the 5 over by adding. So adding 5 to both sides, the result gives us positive 3 on the right. Now we'll need to get rid of the absolute value by making the right side be positive or negative. So we have negative 4x minus 6 over 2 equals positive or negative 3. Now we'll need to undo the fraction by multiplying by 2 on both sides. So 2 multiplied by negative and positive 3 results in negative or positive 6. Now we'll just add 6 to both sides. So we have negative 4x is equal to plus or minus 6 plus 6. Now assuming that the 6 is negative first, that's negative 6 plus 6 is going to be 0. So we have negative 4x equals 0. And then if 6 is positive, plus another 6, that's going to make 12. So we have negative 4x equals 12. Now if you solve the negative 4 times x equals 0, you'll just divide by negative 4 and get x equals 0. If you solve negative 4x equals 12, you're going to get x equals negative 3. If you plug in x equals 0 to see if it works, that's negative 4 times 0 is 0, minus 6 is negative 6, divide by 2 is negative 3. The absolute value makes it positive 3. Take away 5 is negative 2, so 0 works. Now plug in x equals negative 3. Negative 3 times negative 4 is positive 12. Take away 6 is 6. Divided by 2 is 3. And the absolute value is still 3. Then take away 5 is negative 2. So x equals negative 3 is valid, and both answers work. All right, starting with question 10, it says, given the function, graph and state the domain and range. All right, now in order to graph this, we're going to set up a table. Now you might remember that the absolute value function has original numbers in the table set up as negative 2 all the way to positive 2. So negative 2, negative 1, 0, 1, and 2. That would be from the original parent graph. Now, since the x minus 2 is inside the absolute value, that tells us the graph has been shifted to the right by 2 units. So we're just going to add 2 to all of these original x values. The result of that would be our new x values, 0, 1, 2, 3, 4. And again, we got these numbers by just adding positive 2 to all of the original numbers. All right, now to get the y values, we're just going to plug in all of these x values into the equation and evaluate and get the y values. Okay, so without going through all the steps, you guys know how to plug in the numbers and get the values. So we'll just show you what they are. So if you plug in 0, you're going to get 1 for y. If you plug in 1 for x, you'll get 2 for y. If you plug in 2 for x, you'll get 3 for y. If you plug in 3 for x, you'll get 2 for y. And if you plug in 4 for x, you'll get 1 for y. So these are the values that we're going to be plotting on our grid. All right, 0, negative 1 is here, 1, 2 is here, 2, 3 is here, this is 3, 2, and this is 4, 1. And then you just connect the dots and you have this V shape, and that is what the absolute value is supposed to look like. As you can see, this is upside down. It's an upside down V shape, and that is because of the negative that was in front of the absolute value. All right, to finish this, we need to state the domain and the range. Well, the graph is going to push out to the left forever and also to the right forever. So the domain is negative infinity to infinity. Now for the range, the graph pushes down forever, so that's negative infinity, but it pushes up until it gets to 3. So 3 is like the maximum. So our range is from negative infinity to positive 3. All right, here's number 11. This is a cube root graph. So it's 1/2 cube root of x minus 4 plus the 3. Now we need a table first before we graph. And you might recall that the original numbers, the original 5 numbers for cube root for the parent curve is -8, -1, 0, +1, and +8. Now the x minus 4 under the radical indicates that the graph has shifted to the right 4 units. So that means we're going to be adding +4 to each of these original x values. The result of adding 4 to all of these x values are the numbers here. That's -4, +3, 4, 5, and 12. Now let's plug these numbers into the equation to get the corresponding y values. Well, -4 minus 4 is -8. The cube root of -8 is -2. Multiplied by 1/2 is -1. Plus the 3 is going to give you 2. So that's going to be 2. And likewise, if you plug in 3 for x, your y value is going to be 2.5. Plugging in 4 gives you 3. Plugging in 5 gives you 3.5 for y. And plugging in 12 gives you 4 for y. Let's plot the points on the grid. And when you plot the points, this is -4, 2 here. This is 3, 2.5. This point is 4, 3. This is 5, 3.5. And this is 12, 4. And you just draw a smooth curve through those points. Now for the domain and the range. The domain, well, the x values go to the left forever and also to the right forever. So that's negative infinity to infinity for the domain. And for the range, the y values actually continue to go down forever and up forever. They go down slowly and they go up slowly, but they still go down and up forever. So therefore, both the domain and the range are negative infinity to infinity. All right, number 12 is a square root graph. So it's -2 times the square root of x minus 3 plus 1. Let's make a table. And the original parent graph numbers for square roots are 0, 1, and 4. Those are square root friendly. So we'll start with that, the 0, 1, and 4. And then the x minus 3 moves the graph to the right 3 units. So that means we'll take the numbers here and add 3 to each one of them. That gives us new x values of 3, 4, and 7. Let's plug in these x values into the equation to get the y values. So if you plug in 3, 3 minus 3 is 0. Square root of 0 is still 0. Multiplied by -2 is still 0. Plus 1 is 1. And likewise, if you plug in 4, you're going to get -1 for y. And if you plug in 7 for x, you're going to get -3 for y. Well, let's plot those points on the grid. These points here, and this is 3, 1. This is 4, -1. And this is 7, -3. So the graph will begin here and then go downward passing through these points. All right, let's talk about the domain. The domain is going to start here at this point, which is 3 on the x-axis, and then it goes to the right forever. So our domain is going to be 3 to infinity. Now the range, the y values are going down forever, but it goes up to this point, which is at +1. So our range is going to be from negative infinity up to +1. All right, and finally we have number 13. It says to create a square root function with a domain of 5 to infinity and a range of 7 to infinity. Now, since it's a square root function, we can begin the equation by saying y equals the square root of something. Now, since the domain is 5 to infinity, that means that the original curve, the original graph, has been moved to the right 5 units. We would indicate that by putting an x minus 5 under the radical. All right, now since the range is 7 to infinity, we can assume that the square root function, the original, has been shifted up 7 units. We would indicate that by adding 7 on the outside. So this is our final equation. Y equals the square root of x minus 5 plus 7. All right, and that concludes the video on the Unit 7b quiz review.